Hello everybody. In this video, let us solve this trigonometry problem. What is the question? We've been given 1 plus cot A minus cosecant A when multiplied by 1 plus tan A plus secant A is equal to 2. This is what we have to prove. The proof looks something like this. Let us go through it one step by step and see how to solve this problem. Let's look at the first step. So what are we doing in the first step? We're taking the left-hand side and replacing cot, cosecant, tan and secant with sine and cos. Let's take the first one. So we're replacing cot A with cos A by sine A. We're replacing cosecant A by 1 divided by sine A. We're replacing tan A by sine A by cos A. And we're replacing secant A by 1 divided by cos A. So using the trigonometric ratio relationship, we're just replacing cot, cosecant, tan and secant with sine and cos. Typically, to solve these kind of problems, I recommend you do this as a first step. It's much easier to work with sine and cos than to work with cot, cosecant, tan and secant. Okay, so this is the first step. Now let's look at the second step. So what is the second step? The second step is simplification of the terms in the first step. So if you take, for example, this block here, what we are doing is we see that the sine A is a common denominator for these two terms. And if you take an LCM and simplify, this will become sine A by sine A, which means the whole thing becomes sine A plus cos A minus 1 divided by sine A. Similarly, you can see that this term here becomes cos A plus sine A plus 1 divided by cos A. So all we have done is we have basically taken an LCM of the denominator and we have simplified the numerator. Now let's look at this term which is in the numerator. What does it look like? Does it look like A plus B minus A minus B? Let's see. So consider the terms which are in the red. If you see sine A plus cos A is here, cos A plus sine A is here. In other words, the first term is the same. So the terms that are in the red are the same. And if you look at the term in the blue, here it is minus 1 and here it is plus 1. So either we have a plus 1 or we have a minus 1. In other words, this can be seen as A minus B multiplied by A plus B, and we can use the identity A square minus B square equals A plus B A minus B. In this case, A happens to be sine A plus cos A and B happens to be 1. That is what we have done, and we can simplify the numerator as A square, which is sine A plus cos A square, minus 1 square, which is B square. Okay. This is an important simplification, and this makes our further steps easy. So let's look at the next step. Now let's look at the sine A plus cos A whole square term. If you expand this using A plus B whole square formula, you end up getting sine square plus cos square, sine square A plus cos square A plus 2 sine A cos A. And what happens to the minus 1 square? Minus 1 square is minus 1. That remains as is. Now, we didn't talk about this, but since the denominators are just multiplied with each other, they become sine A cos A and sine A cos A. So we're left with this huge expression here. Let us see how we can simplify this expression. Alright, just copied the same expression here and let us simplify. If you pay attention to the first two terms in the numerator, they are sine square A plus cos square A. Using the identity, we can say that sine square A plus cos square A equals 1, correct? You know the identity which says sine square A plus cos square A equals 1. So we can replace that with 1. So you can see that sine square A plus cos square A has been replaced with 1 here. Once you replace with 1, you can cancel this 1 with this minus 1. So you are left with 2 sine A cos A divided by sine A cos A. And they cancel each other. So sin A cancels and cos A cancels. And you are left with 2, which is right hand side. So to solve this problem, we used a bit of an algebraic identity, which was a plus b, a minus b, and a plus b whole square. We used the sine square plus cos square a equals 1 identity, and we used the relationship of cot a, cosecant a, tan a, and secant a with sine and cos. Thanks for watching this video. In the next video, we will solve a different problem. Till then, bye.